All right, properties of parallel lines. One place where you see a lot of parallel lines would be streets. Although in Grandview, I'd say these streets over here to the west of us, these to the right kind of slope down the hill and weave around, which are kind of interesting. But you get these parallel lines cut by transversals quite often with maps. Our first vocabulary or our first postulate, same side interior angles postulate. It says, if a transversal intersects two parallel lines, then same side interior supplementary. So if lines are parallel, then same side interior are supplementary. So let's go here. If 3 is 55 degrees, right here. Find the measure of the other angles using that 3 is 55. What would be the measure of 1? Because it's vertical to 3. What's the measure of 2? Because what makes it supplementary? The relationship is it's a linear pair to angle 3. What about 4? Because? Oh, it is vertical to 2. It's also a linear pair to 3. Okay, what's the measure of angle 5? Because? Now let's relate it, a direct relationship to angle 3. What's 5 and 3's direct relationship? You got it. Alternate interior angles. Now 8, how does 8 relate to 5 or to 3? Sorry. 8 and 3 are same side interior, so what's the measure of 8? Put your Chromebook away. So 8 is going to be 125. What's the measure of 6? Vertical to 8. And the measure of 7? Vertical to 5. Also, how does 7 and 3 relate? They're corresponding. Nice job. Okay. So, obviously we have these other theorems. Alternate interior angles theorem. If lines are parallel, alternate interior angles are congruent. If lines are parallel, corresponding angles are congruent. And so we have all those theorems. Let's go to the next page. I'm going to pause and have you try these reasons, and then we'll go over them. What do we get for line 2? 3 and 4 are supplementary because they are a linear pair. Nice. Now, 3 and 4 add up to be 180 because of definition of supplementary. We have that in the previous line. And then 3 and 6 add up to be 180 because... Now, how are 3 and 6 related in this diagram? They are same side interior. We were given that lines are parallel. And since lines are parallel, same side interior angles are supplementary. So this is same side interior angles theorem. THM is theorem. What allows us to say 3 and 4 add up to be 3 and 6? So it is transitive. It's that connection between the two. You could argue substitution, but we're going to put transitive here. And then what allows us to go to 4 and 6 are equal then? We did something else. Finley?
Subtraction property of equality.
Subtraction property of equality. And now we went from measures being equal to angles being congruent. What is that? Definition of congruence. Definition of congruence. Okay, try the next one. And then we'll go over it. All right, what'd you guys get for 1? Given. Oops. That one was tough. If lines are parallel, then corresponding angles are congruent. Which are the corresponding angles in this diagram? So angle 1 is congruent to angle 5. Good. Now, the measures being equal is our next line, and the reason we can say that is because, now, we would normally put definition of congruence, right? But see how this is written out, congruent angles have the same measure, and that's just what the definition of congruence is. So you could do either. It's just like when we do the theorems, you could use the title of the theorem or describe what's happening. So this is congruent angles have equal measure.
If we have someone who's in a test where it's that written out within the bank.
Okay, 5 and 8 are supplementary. Reason. Good. Definition of supplementary allows us to add them together to set equal to 180. Then by substitution, we're going to get the measure of angle 1, not 5, plus the measure of 8 equals 180. Now 1 and 8 are supplementary by?
Definition is supplementary.
You got it. Very good. Okay. Questions? Do you like having a bank?
I do.
That's pretty nice.
It is nice.
It's quite nice.
Wait, how'd you get 2 and 6 up there again?
A is parallel to B. We are given that these lines are parallel. So we mark them parallel with those extra angles or arrows. 1 is congruent to 2 because the relationship between 1 and 2 is they are alternate exterior angles are congruent when lines are parallel. And I've got lines parallel, so I can say that. Alternate exterior angles are congruent when lines are parallel. Now, I can say 3 and 2 are supplementary because 3 and 2 are a linear pair. So therefore, I can say 1 supplementary to 3 because I'm taking 2 out and replacing with an equivalent value. So what is that? Substitution. So the last one we have is alternate exterior angles theorem. If lines are parallel, alternate exterior angles congruent. But what I want to highlight here is if we've got this 105 degree angle, this 105 degree angle relates to angle 3 in that those are alternate interior angles. This 105 angle relates to angle 4 in that those two are what? How does 105 relate to angle 4? They are same side interior. But what it does not relate to is this intersection cannot directly relate to this intersection. 8 and 105 are not corresponding. They are not alternate interior. There is no direct relationship. You have to go this way and then this way, or this way and then this way. So I can do 105 is supplementary to 4 because they're same side interior. 4 and 8 are same side interior, so they are supplementary. Hence, 8 is 105. You see that? How I went this direction? Or I could go this direction. 105 is congruent to 3 because they're alternate interior. 3 and 8 are congruent because they're corresponding. And then say 8 is 105. But you cannot connect these two intersections. They don't share the same 2 parallel lines. Okay, wanted to highlight that. Let's go to the next slide. In this one, we are finding the value of y. In this slide, what I want you to do, see if you can find what the measure of y is, and then challenge yourself, see if there's another way to get there. Go. So 80 is corresponding here. And so we have 80, 40, and y equals 180. Brilliant. So what's y? Brilliant. Okay, so I highlighted the 2 yellow lines or the 2 parallel lines. Did anyone use the blue transversal? And then this angle, this 40, is alternate interior to this. And then you see the triangle? The triangle would be y plus 80 plus 40 equals 180. And then you could solve it that way, also giving you 60. So multiple ways to get there. Okay, let's go to the next one. Here we have a trapezoid. It's a trapezoid because we have two sets of lines or one pair of lines that are parallel. Now those two lines are parallel. These two other lines are transversals. That's a transversal, and this is a transversal. So how do the two angles here relate? They are same side interior. So how can we set that up? And we can solve that for x and then set up the other two and solve for y. Plug it in to get the angles. Try that. And what do we get for the measures? This 2x is 128. The x minus 12 is 3y is, and the y plus 20 is 60. Nice. Trapezoids. One pair of parallel sides. Okay, go ahead in this next one. Solve for x, solve for y. Then we'll go over it. All right, so the x's, how do they relate? These two angles are a linear pair, right? So we add them together, set them equal to 180. And so we get 2x a nice decimal of 77.5. Now, how do we set up the y's? The two lines here are parallel, and y being down here, would the corresponding angle be congruent? Yes. So then these two angles form a linear pair, and therefore equal 180, and we can solve that for y. And that's going to give us 107.5. Any questions?